This is an example of how to use matrices to solve a system of equations. So here we have a system and it's got three unknowns, x sub 1, x sub 2, and x sub 3. Step number 1 is to write it in augmented matrix form. So we've got it in its augmented matrix, and now our goal is to have the diagonals in the square matrix to be 1. And we look at that upper element here. It's already 1, so everything's fine. What we want now is to look below it and to make sure that everything below that is a 0. So our next goal is to have this 2 become a 0. So we're going to combine rows 1 and row 2 somehow to get rid of that 2. And we realize if we did 2 times row 2 and subtracted, 2 times row 1 and subtracted row 2, we could then replace row 2 and everything would work out. We would have a 0 in that first element, which we have there. So we're going to replace row 2 with that row, which we've done. Our next goal is that we need this 3, this next one, to be a 0. So this is in row 3, the first element in row 3. We need that to be a 0. So we're going to multiply row 1 times 3, subtracting row 3, and then when we replace row 3 with the result, we will have a 0 in that first element. So here we've done 3 times row 1, and then we're subtracting row 3. And then we replace that in row 3. So everything's great because we now have exactly what we wanted. We wanted a 1 in this the top of that column, 1, and then everything below it to be a 0. Our next part of the goal to get this in row echelon form is to have this element right here in row 2, the second element in row 2, to be a 0. So we realize that if we were to switch rows 3 and 2, so that's what we're going to do. We moved up from here all the way up here, and we're going to switch rows 3 and 2, and when we do, we see that we now have a 1 in this element, the second row, second column, which is exactly what we wanted, a 1 here. And now what we want is we want that 4 in row 3, this second element in row 3, to be a 0. So we do 4 times row 2, subtracting row 3, and then replace row 3, which we do. And at this point, we stop for just a minute before we write this and say this is exactly what we want. I notice that I have a 1 in this part of the diagonal, and then a 1, and then I need this to be a 1 as well. And all I really need to do is to divide this row by negative 19, and this element, this third element in row 3, would be a 1, and so I'm going to do that. Divide row 3 by negative 19, which would give me 0, 0, 1, 0, and I'm going to replace this row with 0, 0, 1, 0. And now I've got this diagonal of 1 and everything below it to be 0. So this is row echelon form, which is exactly what my first goal is. My second goal now is to take this from row echelon form and have not only zeros below the diagonal of 1s, but I want zeros above the diagonal. So I am going to multiply row 3, this row here, 0, 0, 1, 0, by 5. Multiply this times 5 and add it to row 2. And when you do that, you're going to end up with 0, 1. The 5s will cancel. So I'd have 0, and then I'd still have a 5. So I'm going to do 5 times row 3, add it to row 2, and replace row 2, which I did. And now I kind of went a little bit farther here, but I need to get rid of, or make into zeros, this second element and third element of row 1. To do that, I have this where I'm going to subtract 2 times row 2 and add row 3. And when I do that, I see that I get 1, 0, 0, negative 1, which now has 2 zeros where the 2 and the negative 1 were. And I'm going to replace that into row 1. And if you look at that carefully, I have 1s for the diagonal, and above the diagonal of 1s I have all zeros, and below that I have all zeros. So this is reduced row echelon form, which means we've solved the system, because I'm saying that the first element, with nothing else here, is negative 1. The second, not the first element, the first variable is negative 1. The second variable is 5, and the third variable is 0. So I can write that as an ordered triplet, negative 1, 5, and 0, and that is the solution to the system.